Hello everybody, today I'm going to be covering how hooking works. Essentially what this does is redirects the program flow so that we can make more edits without having to worry about overwriting more instructions. Let's say that we have a function to hook, and inside we want to overwrite an increment instruction with several instructions that do some fancy math, because we're hackers and we can do whatever we want. What we would do is we would place a jump at the spot inside to hook that goes to our function, where we would then handle the fancy math. Once we've done that, we would then jump back to toHook and continue program flow. If this doesn't make sense right now, I will be showing how it all works at the end of the video. Let's move on to coding our hook function. So the first thing we're going to do is we're going to include windows.h, and we're going to write the prototype for the function. So the first parameter is going to be a void pointer called toHook, and this is the function or the spot that we're hooking. And the second parameter is also going to be a void pointer, and this is going to be the spot that our hook, or the spot that we're hooking jumps to. And then the last is going to be the length, or the number of opcodes that we're overwriting. And so you'll notice on number 1, and it says to make sure that the hook length is greater than 5. So we have to make sure that the length is greater than 5, and if it's not, we're going to return false, because the jump that we're placing is 5 bytes in size, and if the spot that we're overriding is less than that, well, that's not going to work. It won't. It's not enough space. The next step is to change the protection to page execute read write, and it says this makes sure that we can edit the assembly at the location. So for one of the parameters, we have to send in a D word as a reference, well, by address, so that it can take on the old protection or what was. So virtual protect. The first parameter is going to be the address that we're trying to change the protection of, which is going to be to hook. The second is going to be the length or number of bytes that we're trying to change to a different protection, and that's going to be the length. The new protection is going to be page execute read write, which means that we can execute it and read it and write it if that wasn't very self-explanatory. And then we can do the AND symbol, or the address of operator and cur protection, or current protection. And then the next step is set all of the bytes to 0x90 or not, or no operation. And what this does is lets us essentially say we want all these bytes cleared, because if there's any stray bytes at the end of the jump, if your length is greater than 5, that can cause undefined behavior, which is not good. So we're going to set the destination to hook. The value is 0x90 or no operation, and the size is the length, or the number of bytes. The next is get the relative address. So D word relative address, and this is essentially going to be the offset from the jump to where we need to go. So it's going to be our function, which is where we need to go, minus to hook, which is where we're going to be coming from. And so that's essentially the offset from the jump address. Well, jumps that are relative to the address after the jump, so we have to subtract the size of the jump. So for example, if I have label, let's say label, right, and then assembly, I have jump label, it's going to be EBFE, because the size is 2, it's going to subtract 2, which is the size, so that it continuously jumps to the same address, because it's going to the instruction after, and then we have to, subtract the size of that to get to here. So let's say we actually put label after it. So we put label here. Well, then it's going to be EV00, because it's going to be 2 bytes after, or here, if that makes more sense. Next, we have to place the jump instruction. So the first part is we need to convert toHook to a byte pointer and dereference it, so that we can add E9 to the start of it, which is the first opcode in a jump instruction. And then the next step is to convert it to a D word pointer. But first we have to add 1 so that we're not overwriting the E9. And then we can set that to relative address. And the final thing that we have to do is we need to create a temporary variable here, and then virtual protect. And then the address to hook, the size, the length, and then page, or actually we're going to be using the old protection, and then we can put in temp and return true. I didn't do any error tracking for these, so that's all on you if you really want to, make sure. And that's how you write a hook function. So now that we know actually how to write the hook, let's put it to use. Over here I wrote some instructions, but these are mostly for me to keep this video in order. Also, you notice I wrote some DLL skeleton code. I'll have this in the description so that you guys can use it as well. But so step number 1, write your DLLMain naked function, and I'll explain that in a second. So DLLMain naked rfunct, and it's not going to have any parameters. What this means is that there's going to be no epilogue, no prologue, anything I write in here. So let's say I do move EAX, ECX, it's just going to be this. There will be no other assembly but this when it compiles. So that's that. We're also going to add in one more thing, dword jump back addy, and this is where it's going to jump back, and you'll see that when we actually compile and run it, why I have that. So there's that. The next step, get the address that you're hooking at. I wrote a program which I'll be including in the description as well, but essentially every time you press space it subtracts 2 from the player's health, and we're going to hook right here so that we can double it, and this is the address that we're hooking at. So 332768. 332768. The next thing we're going to do is getting the length of the hook, and it says here that you need at least 5 bytes, but another note is that you cannot leave any bytes left out. So we're hooking here, 1, 2, 3, that's not enough, so 4, 5, but we can't leave any bytes left out, 6. So the length is going to be 6, so int hook length equals 6, and then we're going to assign the jump back address, so jump back addy equals hook address plus hook length. So this is the reason why I did this. These two are going to be overwritten, but they're going to jump into here and then execute any instructions that I put here, and then this jump back is going to jump straight back to here and continue program flow. So that's why I have that there. Now we're going to plug the parameters into hook. So hook, the first parameter is going to be where we're placing the jump. The second is where the jump is going to go to, and then the hook length. And that should be, oh yeah, now we need to actually double the health inside our funct. ECX is our health. So we're going to do add ECX, ECX, and then it says make sure to add any overwritten instructions. This one gets overwritten, so we need to replace that. So move, and it says EDX, EBP, EBP minus 8, and that should be it. So, my bad, missed a pointer. There we go. And yeah, now we can compile and run it. So let's compile it. I'm going to go over here and click play and just show you this a little bit. Every time I press space, it goes down, but we're going to change that. Let's go and inject it. And you'll see there's the jump. Oop, my bad. Jump. And it goes here, and there's the code that we wrote in there. And then it jumps straight back right here. So let's place a breakpoint. I want to see this in action. So We press space. Let's step through. It doubles our health over there. Executes the instruction that we overwrote, and then it jumps straight back right after. And that's it. Our health is doubled. If we keep pressing space, it'll keep doubling. Alright, thanks for watching, guys. Be sure to like and subscribe.